there are any uncompleted or incompleted or any other question regarding to the exercise, like including your project. The Aram will cover the such a part. So please bring your laptop on Monday. Then we will have the exercise lab. I heard that the operating system may be okay, but some of the student is quickly dry up the balance of the GCP coupon, because when you create the compute engine, some student create the multiple processor and the huge size of local disk that cost a lot. So we do not use the computing power a lot, just practice the several command and the project. So please reduce the capacity of your virtual machine. Also, it's a good idea when you do not use your compute engine, you can pause to use your compute engine. Then you can save the coupon code. I'm working with Google to get the additional coupon, but not sure yet. Otherwise, you need to pay with your credit card, please. But operating system may be okay so far, because it has only the virtual machine only. But another class like the database, we create the database, use the database instance and the app engine, so on. So it's quick. So please, if you do not use any other service, so you do better clean up. It will be charged. So for your practice, you create several compute engine or other services. So please delete, remove, unused, useless resource. That will save your coupon. So then if I cannot access your project, the end of the semester, you may not get the full credit of your project. That's one thing. The second thing is the midterm is to move to the October 23rd on Monday. Okay, so I have urgent schedule the next week, so I should also. I don't think we can cover the whole chapter 6 today. So please change your schedule for the midterm is October 23rd on Monday, and at that time, so I'm going to create the sample. I'm going to create the sample, exam to check your laptop and connectivity. So like the very simple question, couple of question, but you need to check any requirement, because we are going to use a lockdown browser. Every semester, whenever I use the Canvas for the exam, couple of students fail to learn the lockdown browser. Lockdown browser is kind of software to stick on your browser only. So you cannot use the internet during that time, at that time while you are doing the exam. So, but if you fail to start run the lockdown browser, so you cannot take the exam. There's no makeup exam for after this one. So please check your system and the software. I'm going to probably create this weekend. Then you can install the lockdown browser and check your requirement. Also, this time exam hour is the 1 hour 15 minutes. So there is no early leave. So I allowed to leave earlier those who finish the exam, but I realized some students who leave earlier without finish the exam. Then after they return out of the classroom, they continue the exam because it's online until you finish the finalize. So it's just so smart, the student. So I'm not going to allow the leave earlier this time. And also no cell phone use. The cell phone should be the turn off or the put down on under the desk. So don't even think about such a thing during the exam. Okay. Then exam will cover the chapter 1 through 6, and 40% will be open-ended. So you need to answer or calculate some of the. I think that definitely I'm going to ask a couple of questions from the chapter 6 to calculate the scheduling algorithm. So plus the couple, I think the 4 or 5 open-ended question. Plus the others will be the multiple choices. So multiple choices around 60%. The total is going to be the 100. Okay, any question before we start? So today we are going to hopefully cover the chapter 6, but I don't think we can finish the chapter 6, then continue after the Monday exercise lab, probably the Wednesday, we will continue chapter 6 and finish the maybe okay before the midterm exam. Okay. So this is the computer that we are using. So in the computer there are main components like the CPU and the memory and the other I/O devices such as the hard disk drive, they are connected to the bus. So when we create the process, so far the last I think the 5 weeks, the 6 weeks, we spent a lot of time to regarding to the process management. So when we create the process using the system library such as the Fortran EXEC, by the way, one of the students asked a question regarding to the project. Can I use the Python? Yes, you can use the Python. So, but at the time, the Python provides the OS package that includes the Fortran EXEC. So you need to use the fork EXEC and the wait, the function that mimic. Actually, it's not system library that the mimic. The system library, okay, has the almost similar the argument. So all other the functionality you cannot use, but only you can use the fork EXECLP probably. The fork EXECLP and the wait function. So what about the Java? Java is not allowed. So you need to use other. If you are not sure that you are selected the program language, contact the GA and me. I will confirm whether you can use that program language to practice, to create the processes. So if you create the process, it will be loaded into the memory. How many processes? It's multiple processes are running here. So each process has the PCB. The PCB has all the metadata of the processes. So operating system manages the somewhere, probably it's a memory, the list of the process information as a PCB data structure. Now, one part of the PCB, it has the process state. So process state means the new and ready and running and terminate and the wait. So once it's ready, it's managed by the queue. So we have a number of the processes here. Actually, operating system does not manage the real process by the process, instead of PCB. So it has the PCB information about the process like the P1, PCB P2, PCB P3, PCB. Then one of the processor will be will get the CPU resource, which is the running state. So running state means all the information about the register and the other information. So this the one is used by the P1. Okay, the current process, the running process. If that is done and the end of the program counter is the end of the instruction, it will be terminated and return the resource. Then the PCB information from the operating system will be removed. Then all the used resource will be returned to the operating system. Then operating system the returned resource. Also, this CPU is available, then select another process. Or in case the process need to access the data or the from input and output device, so that will move to the wait. So wait is also managed by the queue to return the response from each I/O devices, especially from the controller. Controller will return the interrupt. Using the interrupt, the return back to the operating system. Then it is managed by each I/O device, as we have seen. So if you remember I think the chapter, I cannot remember the chapter number. So each I/O device has such a queue. Then in case the controller return the response of the requested I/O, then it will back to the ready queue. Okay, so these are the five. Sometimes it's even though there is no the wait, the I/O port, not the wait state, but going back to the ready because it used too many. It's a certain period of time. It's from time to time going back to the ready, the queue, ready state. Okay, at this time, this selection is called the dispatcher, CPU dispatcher, or this is called the scheduling. So scheduling is the algorithm. It's a part of operating system that select the one of the process to be used by the CPU, to use the CPU resource. So we are going to discuss how to select such a CPU, the scheduling, how to select the process. That means there is a CPU scheduling, as we have seen at the last part of the last semester, last class. So there are several algorithms. So we will see the more detail how they are working. Before that, this scheduling is not the first time to see. There are different types of the scheduling in the operating system. If you remember, the long-term scheduling and short-term scheduling, and sometimes the mid-term scheduling. So long-term scheduling is to select process by process from the program. We need to select the process. Think about the MS-DOS. MS-DOS, you type the command like the COPY long time ago. If you never used the MS-DOS, it's the same as similar as the what? The command line CLP. The command line interface of the Windows, but it was the operating system as we have seen. So when the Bill Gates developed the operating system for the personal computer like the Windows, actually it's based on the MS-DOS, such as DOS. Then purchase that, then they add some other functionality. So at the time, selection program by program is called the long-term process. Why? Because it's not every millisecond. It's just after you select the program, it's running sometimes 1 hour, 2 hours until the program is ended. So long-term program. Problem, once it is selected, it's mostly use the resource like in the memory. Okay? So nowadays we allow multiple the process at the same time because we have enough resource, enough memory. So like the running 100 program. Okay, 100 processes at the same time. I have the 8 gigabytes, the memory. So it's not a big deal to select the program by. So nowadays we do not use a lot such a long-term scheduling. Okay, then mid-term scheduling is once it is selected, many years ago, still we didn't have enough memory space. So we need to, from time to time, if I need more space on the memory, instead of terminate firstly, just momentarily move back to the hard disk drive, then to free the memory space. Okay? We will see the operation in memory management later. It's called the swap. So we can move back to the disk drive, then if this one is needed and going back. It's called the swap in and out. Nowadays, even since we have enough resource on the memory, we do not use a lot, the swap in and out. Instead, we are using later, we will discuss about the other operation, that is page in and out. So we will see later. But this is called which one will be selected? It's a midterm. Okay? The schedule. It's also not used a lot. Instead, most of the scheduling is a short-term scheduling. Short-term scheduling is when we have it's a timeline, CPU timeline. So anyway, we cannot increase the CPU time, we cannot decrease the CPU time. What we can do is maximize the utilization. Not just the utilization of one student, but share with many students. At that time, the only way to share my advice time with many students is divide my time by the segment, like 1 minute. Even 1 minute is a very long time for the CPU time. So it's a millisecond level divide. Then assign this is P1, this is P2, P1, P2, P3, P1, P, something like that. Okay? So for that selection is called the short-term scheduling. So when we talk about the scheduler in the CPU, that means it's a short-term scheduling. One more thing is whenever we select a new process like the selection, this dispatch, or the scheduling, what happened in the CPU? What happened? We need to change all the information about in the CPU by the new process, right? So copy, back up all the data, including process state and the scheduling algorithm, memory, all the information back up to the where? PCB. Always PCB. It's in the RAM, but it's in terms of data structure, PCB of that process. Then bring the selected process information to the CPU. Where is that? It's also PCB. This one is called context switch. So context switch is, the more context switch is better. It's a fair too. The more time I switch it, okay, change the student to advise, okay, then the student can do something. However, during the transition time, I cannot do anything like if student out and next student coming in, it takes 30 seconds. During the 30 seconds, I cannot do any other thing. I cannot do the advising, which means the more context switch is the overhead. Okay? The less, you cannot have the higher degree of the programming. So it's very important to balance the context switch overhead versus the performance and the degree of the programming. So that is a context switch. Then the remainder is how to schedule. That is the main discussion of today. So we are going to see how we with some example. It's not very complicated as we discussed. Oh, but before that, so we have the certain scheduling algorithm. 1 scheduling algorithm, 2 scheduling algorithm, 3. Now which one is better? Which one is better than the other? To judge, that is called the evaluation. To evaluate the algorithm, so we discussed about the evaluation method. One is we'd like to maximize utilization. Okay? Like the idea is 100%, but 100% is not always the best because most of the case 100% is infinity loop. Okay? So anyway, but we'd like to maximize the utilization. Yes?
So we use algorithms for short-term scheduling process. For mid-term and long-term, is it just hardware or other algorithms involved too?
Oh, it's algorithm, okay? Or nowadays we do not use. Sometimes the long-term scheduling can be managed by the manually, like you just type the command or click. Or one of the examples of such a long-term scheduling is a printer. Printer job, so when you submit the printer job, can you stop and resume later? No. Once it is started, then you can provide priority. My printing job is very important, so if you provide a higher priority, that will be selected. Once selected, the other printing job should wait. So nowadays, printing school uses such a long-term scheduling algorithm. So then the midterm is not used a lot, but in case we need to swap in and out, and which one will be swapped out? Which one will be selected? At that time, we can use the midterm scheduling, but mostly the current operating system do not use such a long-term and midterm. Instead, whenever we talk about the scheduling, that is a short-term. It's a millisecond level switch. Okay, then one category, the evaluation method is to maximize the utilization. But in our discussion, we are not going to consider context switch overhead. During the transition time, little amount of time is useless CPU time. Okay, but we are not going to consider such a context switch overhead. Okay, that exists in the real system, but in our discussion, so we to focus on the algorithm, we are not going to consider. And then there is another one to judge how fast response. So response time. So response time is the faster, is the better, or the longer is the better? Faster is the better. So it's the minimize the response time. So what is the response time? When I ask the question, you probably think the answer, okay, for perfect answer. Then it takes 1 day. So tomorrow you will answer, right? But his answer is always good, the perfect. But the another student quickly answer whatever he is thinking, okay? Why he is talking about the answer that he correct and then so finally answer. So regarding to the response time, his answer is good, but regarding to the accuracy may be different. But in scheduling algorithm, we expect something first response. So response time is the period, amount of time, request, and first response. It doesn't matter how long it takes. It doesn't matter whether in the middle of the scheduling is wait or the something either. It doesn't matter. Just the first response. This is the response time. We try to minimize the response time. Then turnaround time. Turnaround time is the total amount of time that finish the job. Okay? The start and end. It doesn't matter how long. It matters if the process wait a lot, but you need to consider all of this waiting time, CPU time, waiting time, CPU time. Total amount of time is the turnaround time. Also minimize. And another thing is waiting time. Waiting time. Waiting time means while this process is running, not always takes the CPU time. In the middle of the process, sometimes wait in the ready queue or wait in the wait queue. So this amount of time is called the waiting time. So our goal objective is minimize such a waiting time. And another thing is the throughput. So considering these are always average in case a number of processes, right? If you are running the 10 processes, we are going to calculate each of them response and the average. And the turnaround time and the waiting time, it can be average. But sometimes we can judge the performance of the scheduling, how many processes are done, okay, completed. That is a number of throughput. Number of throughput is maximize. We try to maximize the number of processes that are completed. So this is our goal. Among them, we are going to mostly use response time and the waiting time to judge whether the scheduling algorithm is good or not. So the difference is response time is starting and first response. Waiting time is a total, including this, total amount of waiting time until the completed. Okay, that is the waiting time. So using this one, so we are going to see the algorithm. The most basic algorithm is such a thing that we discussed. I complete all the algorithm within 5 minutes last class. Do you remember? So we will see details of them. So to do that, to simplify the problem, from now on, I'm going to use this one, process state. Okay? Actually, where can you find such information? Process information. PCB. Okay? In the PCB, the process ID is 1, and arrival time is 0, and burst time is total amount of CPU time to be terminated. To be terminated, how much CPU time we need? This is 24. Let's say the unit is millisecond, for example, but I'm going to omit the unit of the each number, but you can imagine the kind of millisecond. So, for example, P1 needs 24 milliseconds to be completed, to be terminated. P2 needs 3, and P3 needs 3, but they arrive in the different time, 1, 2. Okay? And another assumption is single CPU and single core that we are using. Okay, then this is called the process state, process information. So we are going to use this process, the given process information to judge, to understand the CPU scheduling algorithm. And another thing, to simplify, we can use the kind of timeline with the arrow, or for better understanding, like it's called the Gantt chart. This is nothing but this horizontal line represent indicate the time, CPU time, and there's no meaning with the height of the distance for better understanding. So let's start. Oh, one more thing is, I strongly suggest the first conclusion or the simple algorithm is very easy to understand. So in your mind, you can understand everything. But it's totally different from in your the midterm or the final exam or your exercise. It's more complicated than you cannot understand all the problem in your mind. Okay, so I strongly suggest to manage the PCB and other the very basic information about like the cube, ready cube, something like that. I will give the example. So in this case, first we are going to do the time chart. So 0 to let's say the 30 seconds. If we need it, it can be extended. Then we need to manage at least a ready queue. And also each process is running queue and terminate queue. At least in this example, we are not going to consider the wait queue, wait state, because if we need to consider the wait, it's more complicated. So to focus on algorithm itself, we ignore any wait the state. So we do not have the I/O read in this example. It's only CPU. Then, so in the ready queue, for each ready queue, we are going to manage the PC. For example, P1, the current time. Time is when time is 0. Process 1 is alive. So P1 is alive to the ready queue. Then at the time, arrival time is 0 and CPU burst time 24. What is this? Let me use the different color. So P1 alive 0 and 24 CPU burst time. What is this? This is a PCB. Okay, very simplified PCB data structure to keep all the information about the process. In real case, it will be much more complicated. It has a PID, PPID, and the process state and register information for each register. But this one is only the needed information for this problem. So I simplify our PCB. So P1 is alive here, at time 0. Then, first algorithm is the first come, first serve. Means the earlier arrival time will be selected. So at time 0, there's no process is running, so this will be selected, definitely. So P1 is selected. P1 will move to the running queue. Okay? Then at time 1, so what happened? P2 is alive. P2 is alive. The arrival time is 1. and the CPU burst time is 3. So at time 1, this is the status. Okay? Then this time there are two options. One is the preemptive, and another one is the non-preemptive. What does it mean, the preemptive? Preemptive.
Stop the first.
It can be resumable. You can pause, then start, and what back up, then use it again. So from now on, we will use several times in operating system for the preemptive. So whenever you see the preemptive in operating system, it can be the resumable. It can be restarted. Okay? It can be back up and use it again. Non-preemptive means once it is done, it's done. You cannot reuse. So in this case, the CPU scheduling, there are two options. One is a preemptive and another one is non-preemptive. Means non-preemptive means once process is selected, it will use the CPU time until termination. That is the non-preemptive. In case of preemptive, CPU scheduling will select the next process whenever there exists event. Okay, like the alive. But this time we are going to use the non-preemptive option. So non-preemptive option means the P1 continue to use. P1 still is in the running queue. Okay, until when? Termination. So before termination, there is another event at the P3. P3 alive at time 2, and CPU burst time is 3. Then the time is the 2. Then P1 still use 1, 2, P1. Then this is the current time, the current state. 3, 4, 5, 6 is the same thing until when? 24. At time 24, what happened? P1 is terminated, so it moved to the terminate queue. Terminates, it's not queue. It's not queue. Terminate, the P1 is done. It's a 0, 24. So time 24. Then CPU scheduler will select the next process from the ready queue based on what? First come, arrival time. So we will check the arrival time. P2 is the earliest one. Move. Okay, then the P2 is running in the CPU. Until when? 27. 27, P2 is done. And this one is done. Then this time CPU scheduler will select next process, that is a P3, and running P3.